Hey, we're solving some linear systems, but we have a new method. We're going to solve the linear system using elimination. So our goal is to solve, so that means whenever we have a solution to a system, that means our answer is a point, right? We've got two lines meeting somewhere. Where do they meet? That's what we're trying to figure out. So, for example, we've got this one equation, 3x plus 4y equals 8, looking here. And our second equation is negative 3x plus 5y equaling 10. So we want to know, where do those two lines meet? So we could graph them. We learned that. We could use substitution. We learned that. Well, now we're using elimination. And what elimination is think of the word eliminate. We're going to eliminate a variable. So what we're looking for is the same but opposite coefficient for either variable, for your x or your y. You also want them to be lined up in standard form. So I have ax plus by equaling c for both of these, So do I have a same but opposite coefficient? 3 and negative 3, are they the same but opposite? Yep. Do I have one here, 4 and 5? Nope. But it doesn't matter, I have it here. You only need it for one of the two variables. So if that's the case, same but opposite, you can just add both equations and elimination, that part of the problem. So I've got here 3x plus negative 3x. You see I'm adding 3x plus negative 3x. That's gone. And then I have the rest. 4y plus 5y, 9y equals 8 plus 10, 18. What? How awesome is this? So I have 9y equals 18, divide by 9. I get y equals 2. So that's my y coordinate. I just need my x. So I plug in y. And you could have picked either equation. I picked the first one. So I have 3x plus 4y equals 8. Plug in 2 for y. And then I have 3x plus 8 equaling 8 after I multiply 4 times 2. Subtract 8 from both sides. You have 3x equals 0. Divide by 3. You have x equals 0. So that's your x coordinate. That's your y coordinate. What's the point that they meet? 0, 2. That's your answer. Love elimination. All right. So here, example 2, I've got 5x plus 6y equaling 4. Ignore the parentheses in purple there. Just look at the black part. I have 7x plus 6y equaling 8. So my question here is, do I have the same but opposite coefficients for either variable? Well, I've got a 5x and a 7x. So 5 and 7 are both positive, not opposite, and not the same number. Let's look at the y. I've got a positive 6 and a positive 6. They are the same number, but they're not opposites. So I'm going to have to do something to the equation in standard form to make it the same but opposite, right? So I could pick either one of these. I picked the first one, and I'm going to multiply that whole equation by negative 1. Remember, in standard form, you can multiply equations and they're still equivalent. So that's what we're going to do here. We're going to multiply 5x times negative 1, get negative 5x. 6y times negative 1, get negative 6y. And 4 times negative 1, which is negative 4. Then I line up my second equation below it, and I have negative 5x plus 7x. I have a negative 6y plus 6y. Hey, they're the same but opposite. And I've got my numbers here, so I can add. I'm ready to eliminate. So I'm eliminating my y coordinates, and I'm working with my x only. Negative 5 plus 7 is 2x, and equals negative 4 plus 8 is positive 4. So I have 2x equals 4, divide by 2, and x equals 2. Now I need to plug x in, and you can pick either equation. I picked the first one, so I have 5 times x plus 6y equals 4. And then I put 2 in for x, because remember x was 2. 5 times 2 is 10. 10 plus 6y is 4. Subtract 10. I get 6y equals negative 6. Divide by 6. I get y equals negative 1. How fun is this, right? Yes. Okay. That's going to fall. All right, fix that. So number 3, we've got in black here 2x plus y equaling negative 9 and 4x plus 11y equaling 9. So I'm looking at my coefficients. First of all, they're both in standard form. Sweet. Now, do I have the same but opposite for my coefficients? Well, I have a 2 and a 4. Nope. And what's my coefficient here? It's a 1 and an 11. So neither case has the same or the opposite. So I've got to do something. I could either multiply my first one, right? by a number to get the same but opposite here, or I could even multiply my second coefficient, my y, to do the same but opposite here. I chose to eliminate my x's, so I multiplied I multiplied the whole equation by -2, because 2 times -2 is going to give me that -4x, and that will eliminate my x by being the same but opposite. And then I have to multiply everything else. So positive 1y times -2 is -2y. Equals -9 times -2 is positive 18. So now I have -4x plus 4x. Gone. Ready to add. I have a -2y plus 11y. That's a positive 9y. Equals 18 plus 9, 27. Divide by 9, I get y equals 3. So then I need to finalize my answer, but I'm not done yet. All I know is that y equals 3. Remember, I still need my x value. That's a terrible 3. One more time. I need a new marker. So I need to plug in my y value in for my equation, either one. I picked this one, 2x plus y equals -9, and y is 3 because that's what I got. And then I have 2x plus 3 equals -9. Subtract 3, I get 2x equals -12. Divide by 2, I get x equals -6. So my answer is -6, 3. Okay, and then I want you to try this one. It is definitely a bit more difficult. You have 2x plus -3y equaling 6 as my first equation. And my second equation is 4y equals -7x minus 8. Try it for a second. Unpause the video when you're done. So this is in standard form. I'm not going to do anything to it yet, if at all. This one's not in standard form, so I need to move my 7x by doing the opposite to both sides. And I get 7x plus 4y equaling -8. Now I gotta think, okay, do I have the same but opposite? 2 and 7? No. So I have the same but opposite? Well, I have the opposite, but I don't have the same. So I'm gonna have to multiply. Can I multiply 2 to get 7, or 3 to get 4, or 4 to get 3, or 7 to get 2? Not really, not without dealing with fractions. So I'm actually gonna have to multiply by both equations. Since this is already the opposite, I'm going to go with that one. It just seems a little bit easier. Maybe it's not. I'm not sure. So if I multiply both of them, I'm going to have to multiply the top by a certain number and the bottom by a different number, where it gives me the same but opposite. So I'll multiply the top by 4 and the bottom by 3. So my top equation, 2x times 4, 8x. -3y times 4 is -12y. 6 times 4 is 24. Okay, 7x times 3, that's 21x. 4y times 3, that's 12y, equals -8 times 3, it's -24. Uh-oh, that's okay. So now I'm going to add and eliminate. Okay, so 8x plus 21x. I don't trust this. 8x plus 21x is not 29x. 12y and positive 12y cancels, equals 24 and -24. I mean, we could write cancels, but we need something there. So that happens to be 0. So 29x equals 0. Divide by 29, and x is 0. So it's not like there's a problem here. It's just that the x value is 0. So now you have to plug in x into either x, 0 into either x. I'm going to pick this first one, that 4y equals -7x minus 8. So 0 for x, so this whole term is 0, minus 8 equals 4y. And then I divide by 4, and, well, 0 minus 8 first, which is -8. Divide by 4, and y equals -2. So now what's my ordered pair? Well, the x has to come first. What's that? Oh, it's 0. My y comes second. Oh, that's -2. So that's your answer. It does land at 0, -2.